We are widely taught to view condoms as an equal opportunity shield, a universal barrier providing the exact same level of physical protection for both partners involved. In 2015, a detailed study examining how genital herpes, or HSV2, transmits between heterosexual couples tested that basic assumption. This chart illustrates the study's risk reduction findings. When an infected man uses a condom correctly, transmission risk to his female partner drops by 96%. But when roles are reversed, the male partner's risk is only reduced by 65%. The couples are using the exact same physical latex barrier in the exact same way. Yet there is a 31-point gap in effectiveness dictated entirely by the gender of the infected partner. A statistical gap of that magnitude cannot be explained away by looking for manufacturing flaws in the latex. It reveals that our basic public assumptions about how the herpes virus travels from person to person are missing a crucial variable. When considering sexually transmitted infections, the default public picture is a pathogen traveling exclusively through the exchange of bodily fluids. For those specific fluid-borne infections, a physical pouch serves as a near-perfect containment trap, sealing off the exchange at the source. HSV2 operates under a different set of rules. The primary driver of transmission is not fluid exchange, but rather a process known as asymptomatic shedding. As we see in this microscopic view, viral particles are pushing their way out and detaching directly from the surface of unbroken skin cells. The skin tissue itself becomes highly infectious, even when there are zero visible sores or outbreaks present. Because herpes spreads through direct skin-to-skin contact, the real-world effectiveness of any barrier is entirely dictated by which specific patches of infected skin actually get covered up. To map this out, we have to establish baseline biology. Women generally have a larger surface area of vulnerable mucous membranes, which naturally increases their biological susceptibility to transmission. This diagram highlights the penile shaft. For infected men, this localized area is the primary surface where the virus sheds. When a condom encapsulates that area, it securely traps the virus behind a wall, creating that 96% success rate for male-to-female protection. In women, the virus sheds across a broader external landscape, the vulva, labia, and perineum. A condom only covers the penis, leaving a man's scrotum and base completely exposed. During sex, this unprotected skin rubs directly against these infected zones, bypassing the latex entirely. Condoms do not have an inherent gender bias. They simply happen to fit the tight spatial geometry of the male shedding site perfectly, while the broader geography of the female shedding site easily outflanks the barrier. Recognizing this anatomical blind spot shouldn't prompt anyone to abandon barrier methods. A 65% reduction in risk is still a massive statistical advantage compared to zero protection. Leading health authorities point out that condoms remain a meaningful, non-negotiable tool for basic risk reduction, despite falling short of absolute perfection for skin-to-skin contact. To close the 35% gap left by human anatomy, patients have to combine physical barriers with chemical defense in the stacked strategy. This lab image highlights the next layer of defense: daily antiviral suppressive therapy. When taken regularly by the infected partner, these medications drastically suppress that asymptomatic viral shedding right at the cellular level. You complete the stack by maintaining open, honest communication with your partner and completely avoiding sexual contact during active, visible outbreaks. The ultimate takeaway here is stepping away from the false sense of absolute security provided by a single product. True protection requires an informed, comprehensive strategy that accounts for the literal physical limits of human anatomy.